Hello. Today we're going to be going over a quick tutorial on how to use the equation solver again, and then also how to do it the same thing in Desmos. So on the first couple days of class, I went over it really quickly, but I thought I would do a little more in-depth of a tutorial. So let's get started. So remember that you can get a TI-84 from the Math Success Center. You can also get an online one. Just go to this calculator loan program. There is a lot of options. We need to use the second option for this. 1 and 2 both link to the same calculator. That's going to be this one. And it actually has a lock on our numeric solver. So even if we try, we can't enter it. So let's just close that out and go to the second one. So to get to this menu, we're going to start at the home screen. Then we're just going to click Math, go all the way down, and you're going to see Numeric Solver. Just click Enter to get into that menu. And then we could put two equations with whatever variable we want to solve for. So say I have an equation 8x. I'm just going to use this x. You can also use alpha, and then whatever variable you want. If I want f, 8x, and let's say we need that to equal 2. And we want to know what x is equal when both of these are true. So we're going to click Graph, and then we're going to click Solve. And that's just going to be the graph button again. And now we have x is equal to 0.25, or 1/4. And we can also confirm that using our standard y equals menu. We'll just type in 8x and then 2. We're going to click Graph. We're going to zoom in. And let's zoom in about where that intersection is. That looks good. Now let's go second, Trace, to get to the Calculations menu. Scroll down to Intersect. Enter. We're going to select the left side of one of our functions and the right side of our other function. That's good. Click Enter. Click Enter. And then we can see our intersection, x is equal to 0.25. We can also use our y variable instead of typing out our equation. So again, we're going to go to Math. You could either scroll all the way down or just click the up arrow to go all the way to the bottom. Click Enter, and then let's clear this, and we're going to use this vars option, or variables. So we're going to click that, tab over to the right where it says yvars. We're going to use our function. We want y1 in equation 1, and we're going to go down. Let's clear that too. We're going to go vars, yvars, function, and then we're going to scroll down to y2, enter, okay, and then solve. And we're going to get the same answer because they're the same equations. We just used y1 and y2. You can use the same principle in many other ways. Now let's go over how to do that same thing on Desmos, which is quite a bit easier and has a couple more features. Let's go over to Desmos. Let's pull up this example. So I have two functions, f of x and g of x. F of x is equal to x squared. That's our purple parabola here. G of x is equal to 3 times the square root of x plus 1. And that's going to be our black square root function over here. Now, we're just going to zoom in a little bit, and we can see a point that shows up right here, a little gray point. We could just hover over that, and that's going to be our intersection point. So that's not only going to be our x value, it's also going to be our y value, which is really useful so that you don't have to do a couple more calculations. And that's our intersection point. Pretty easy. Let's move on to example 2. This time we're given f of x is negative 2x, and we're not given a y equals x function, we're given an x equals something function. And it's not a function, it's a relationship. If you remember from early on in class, this does not pass the vertical line test. But we can still find an intersection for it. So let's see here, we want to zoom in to our intersection point, and let's go through, and we can see a little point up here, and that's our intersection. So these are going to both be equal at 2, negative 4. So if we're looking for our x value, it's going to be 2. If we're looking for our y value, it's going to be negative 4. Let's move on to the next example. Here, we're given 2 horizontal lines. Both are our y equals 2. Sorry. And they're going to be the same function. No matter how far you zoom in, right? They're always going to be the same. So you won't have an intersection point because every point will be an intersection. So if we're given, hey, what are the intersection points for these two functions? It would be all real numbers, because every number out to infinity, it's going to be the same function. We could just confirm that by, let's hide f of x. G of x is in the same spot. Let's move on to our last example. Now we're given a couple more functions. This time, you'll notice that we have more intersection points. So there are going to be multiple spots where these functions equal each other. So f of x here is a cubic function where with the roots 2, 1, and negative 3. We can confirm that just by clicking on the function, and then these points pop up automatically of where it crosses the x-axis. So we have that root negative 3 right here. We have 1 right here, and 2 right here. And then we're given just a standard linear function of 1/2 x. And since we have 3 different equations, three different intersections, we're going to go through same exact process. We have this point here. Let's copy that point down. You could just click the button to the right side of our intersection when we hover over it, and that'll make a new point. There we go. And there we go. And another thing that we can do in Desmos that's really nice is we can make a set function. So we're going to type x is equal to, and then we're going to type our square brackets, and we're going to get a list. Right now it says empty list. And we could just go through. We're going to highlight this, Control C, Control V, and then we're going to type a comma. Then we'll highlight the x value of our next point. And then we'll do another comma. Same process. And now if we hide these points, we'll have the x values of where that link was true. We can do the same thing with a y set. Just gonna copy and paste all of our y values now. And now we have all our y values. It's much easier to read. You could add some spaces there. Now you can save that for your future reference. That's going to be all for today. I'll link this graph below so you guys can run through it again.